So that's a left tail test setup, just starting again. And then a right tail is we shade the right side of it, the right tail. And that would be that the null or alternate hypothesis is the mean is greater than. So that is alpha, which is the rejection region. Sorry, I have an alarm set for this class. Sorry. So this is the non-rejection region again, when it's not shaded. And then a two-tail test is when the null or alternate hypothesis is not equal to. And that means that there's two tails. And whatever alpha is, we divide it in two, and the rejection region is still the shaded part. So the shaded part is always the rejection region, the non-shaded part is the non-rejection region. So we're going to do some math, and then we're going to see where a test statistic falls. If that test statistic or sample statistic or test value, it's called all different things, falls in that rejection region. So if it falls in the shaded region, then we reject the null hypothesis. If it falls in the non-rejection region, so the not shaded region, we do not the null hypothesis. In this decision, it's always talking about the null hypothesis. And just to fix this, it's a big zero, but it doesn't matter. So we always talk about rejecting or not rejecting the null hypothesis. So we don't make any other decision besides for that. Reject or do not reject the null hypothesis. And again, we can use the abbreviations DNR if you want to. Some people forget that though, but that N stands for not. Writing a conclusion is the next thing. And the conclusion is one of these four sentences. If the claim is the null hypothesis, your answer is going to have the word, or your conclusion is going to have the word reject in it. If my pen has been acting up all day, even worse than normal. If the claim is the null hypothesis, then you use the word reject in the sentence. If the claim is the alternate hypothesis, you're going to use the word support in the sentence. If this has the word not in it, this sentence is going to have the word not in it. I'm going to throw this pen soon. So support is for the alternate hypothesis being the claim, and reject is for the null hypothesis being the claim in the sentence. The rest of it stays the same. All that stuff that isn't highlighted, we are either going to say there is or there is not. So there is or there is not enough evidence to. There is or is not enough evidence to. Either reject or support the claim. We never deviate from those words. Don't make it more flowery. Don't make it shorter than it is. Don't say support the null hypothesis or or whatever you want to change. Don't change it. It can be one of those four sentences. But again, the decision is always about the null hypothesis. If it has the word not in it in your decision, then your sentence is going to have the word not in it. So I can flip back and forth with this, or if you have it in front of you from yesterday or the day before, whatever day that was, we're going to go to what we're doing today. So we'll go through the steps as we do the first problem together. And most of, or all of these steps we've done before, we're just putting them together in one problem. For this section, we are going to use a z-test for a mean, and there's two different methods: rejection regions, which is also called the traditional method. Depending on which book you use. I think our book does say the traditional method. I do like saying the rejection regions because we're using rejection regions. So some books will say one, some books will say the other. I use rejection region just because it makes more sense to students. So we're going to use a z-test. Remember from chapter 7 with confidence intervals, the population standard deviation is known. If the population standard deviation is known, then we use z. Section 8.3, we're going to use t because the population standard deviation is not known. And then the rest of the sentence, don't worry about it because that's always going to be true. And then we state the hypotheses and label the claim. And I also label all of the other stuff. So remember, I start my problem the same way. So in Pennsylvania, the average IQ score is 104.5. That's the population average. The variables normally distribute, which we have to be told, and the population standard deviation is 15. Because the population standard deviation is known, it is going to be a z-test. A superintendent claims that the students in her school have an IQ higher than the average of 104.2. So this superintendent is claiming that her students have an average higher than that. So because it says that it claims have an IQ higher than the average, the null or alternate hypothesis is going to be the claim. And if you get stuck on a part, you might get stuck on which one's the claim, or how do you tell if it's a right tail, or whatever. Whatever part you get stuck on, make sure you clarify with me because I've seen it all. Like you might get everything except this one little piece. So just make sure you let me know if you don't get a piece. She selects a random sample of 30 students and finds that mean, so the sample mean is 106.4. Test the claim at 0.05. And so that's all pretty easy stuff. We just labeled everything. I forgot to put the 104.2 here. So we did steps 1 and 2. Step 1 was to identify the population standard deviation, and step 2 was to write the hypotheses and label the claim. Step 3 is to find the critical values and rejection regions based on alpha. So I'm going to draw the rejection regions first. So it's a right tail test. I know I have to not switch. Shade the right side. And this is alpha. Alpha is the rejection regions. What we get here is that critical value. So Z sub C, in order to find that, we need to do the inverse norm. Sometimes you do the inverse norm of alpha. Sometimes we do the inverse norm of alpha over 2. If it is a one-tail test, if it's right tail or if it's left tail. We use the inverse norm of alpha to find the critical value. So the critical value is alpha. I'm sorry, Z sub C. If it's a right tail test, Z sub C is going to be positive. If it's a left tail test, Z sub C will be negative. Confidence intervals, we always used positive for Z. Now we're going to use the sign. For two-tail tests, it's half of alpha in each of the tails. And Z sub C will be negative and positive. So the critical value is found within the inverse norm. So this one is a one-tail test. So we do the inverse norm of alpha. Which was, 0.05. If we do that, I get out a negative 1.64, but this has to be a positive 1.64. We need to use a positive because it's a right tail test. So that is the critical value. And we say that it's Z sub C. Some people write Z sub alpha or Z sub alpha over 2 or Z sub 0. If it has some subscript, it means it's that inverse norm. Remember that the shaded part is the rejection region and the not shaded part is the not rejection region. The fourth step is to find the test statistic or test value or sample statistic, whatever that is, could be all different words. We just use the letter Z. We don't use any subscript. And this formula we used before, it's the sample mean minus the population mean over the standard deviation divided by the square root of n. That formula should seem very familiar to you because we used it a lot. So my test statistic Z equals sample mean minus the population mean divided by the population standard deviation divided by the square root of n. You can either do that out or trust me, it's 0.8033. So my test statistic is 0.8033. Going back up to here, critical values, inverse norm. Test statistic or test value, we use that formula. And then we see where that falls. 0.8033 falls somewhere to the right of 0, but to the left of that number. It doesn't matter where exactly you put it on the number line, just as long as you know it's to the left of the rejection region. You don't even have to have that median or mean marked. It's in the not shaded region, which is the non-rejection region. So this is my fifth step. If it's in the rejection region, then you reject the null hypothesis. If it's not in the rejection region, then you do not reject the null hypothesis. It's in the non-rejection region, so you do not the null hypothesis. And then the sixth step is to summarize your results, which is the conclusion. which is one of the 4 sentences from that table. So you can look back at that table, and the sentence always starts off with there is or there is not enough evidence. There is, I'm just going to leave a little space just in case, enough evidence to blank the claim. Those 2 lines are always going to be filled in. Or it might not be not. So since it's in the non-rejection region, we do not reject the null hypothesis. Since it's in the non-rejection region, there is not enough evidence. And then we have to decide if it's support or reject. Since it's the alternate, since the claim is the alternate hypothesis, then we write support. So there's a lot of steps in these problems. I know that there is. And it might seem like I'm never going to get my brain around this, but you will. You absolutely will, because we're going to do it. The next thing we're going to do is this with a p-value method, but it's the same, almost exactly the same. And then we do this with a z-test or a t-test. So that's what this whole chapter is and the rest of the year. This middle part might be a little bit different, that very middle column, but the left is going to be the same and the right's going to be the same. All right, what we're going to do is go through number 2. I'll go through number 2, and then 3 and 4, I will make a video after this lesson and post it so that you guys can try it on your own and then check the video if you have any problems. But I want everybody to be able to work at their own pace and not hear me talk about it, and for you guys to do it on your own. So we always start off the same way, our null and our alternate hypotheses. Researcher claims, so I hear the word claim, that the mean cost of raising a child from birth to age husband, blah, 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 is blank. So the researcher claims. In the one above, it claims that it is, it was higher than, so claims that it is 13,850. So the null hypothesis is the claim. Then the other one is always going to have that same number. Since there's no greater than or less than, it's going to be not equal to. Random sample of 500 children has a mean cost of 13,725. Assume the population standard deviation, so I know it's going to be AZ, is 2, 3, 4, 5. At alpha is equal to 1.0 or 0.10, is there enough evidence to reject the claim? So that word reject gives me another hint that the null hypothesis is the claim. If we're talking about rejecting the claim, it always has to be the null hypothesis. So that was steps 1 and 2. Step 3 is the sampling distribution with the critical values. This is a two-tail test. So we do the inverse norm of 0.05 because it's alpha over 2. Since it's a two-tail, we divide alpha in half. the same as before, which is 1.64. That was our critical value, and now we're going to find the test stat. On your test, it's going to say critical value test statistic. If you get them wrong, especially because you have your notes in front of you, you're going to get a lot of points off. You have to know the words of it and also how to find them. So we use our formula, and it's 13,725 minus 13,850 and we do get that. Which is negative 1.19. Then you see where that falls. This negative 1.19 again is in here. It's in the not shaded region. So our decision is only either reject or do not reject the null hypothesis. Since it's in the non-rejection region, you do not reject the null hypothesis. Again, since it's in the not shaded region, we do not reject the null hypothesis. And the conclusion, there is or is not enough evidence to either reject or support the claim. So since it's a non-rejection region, we do not reject the null hypothesis. And if we do not reject the null hypothesis, there is not enough evidence. Because the null hypothesis is the claim, we talk about rejecting it. So there is not enough evidence to reject the claim. And this sentence also here tells us a very important thing. So I know it's a lot of steps. It's not hard if you practice. If you practice, you're going to build that muscle memory and you're going to get to remember how to do it. You guys are all capable of all these steps. It's just taking them into one and knowing the different words. Say them, write them over and over again. Anybody have any questions before you leave? Okay. If you do, you can stay on. If you don't, you can log off. Again, do 3 and 4. Oh, I'm sorry, not yet. Sorry. You also have this on the video and on the paper. Put your homework problems. I forgot to do your assignment guide. It's on page 435. And it's those 5 problems in your book. I know how you guys love doing book work. So you're going to use the rejection regions. I think it says traditional method, but you're going to use rejection regions. So those 5 problems also for 3 and 4, I'm going to record them now on a lesson on Screencastify and then post them also.